Hello everyone, hope you all are doing well. So today we are going to topic 13C of weed science. We have already discussed topic 13A and topic 13B. So today we are going to discuss topic 13C, that is third lecture of weed science. So starting with a very popular topic, that is, what is integrated weed management? Integrated weed management, that is IWM, integrated weed management. So it comprises of four methods. So the first method is mechanical method. How will you manage weeds mechanically? Here we can use tillage, we can do hoeing, hand weeding, that is weeding by hand, digging, that is digging soil so that we can uproot the roots of the weeds, burning, sickling, that is use of sickles, mowing, etc. So these are some common mechanical methods. Now moving on, what are cultural methods? Cultural methods of weed management. The common cultural methods are crop rotation, intercropping, that is growing of intercrops, mulching, that is covering by soil through some layer of, we can use some biological mulching in such as grasses, long grasses, leftover paddy, stubbles, etc. You can use many things. We can also use plastic seeds, polythenes. We have discussed mulching earlier also. For what it is used? To conserve the soil moisture. So very important mulching. Use of proper varieties. Proper irrigation. Proper irrigation and drainage. So these are the some of common cultural practices. Now moving on, what are biological methods? Now moving on to biological methods. So first of all, what we can do? Use of insects. For example, the Euloplata girardi. It is insect which helps in controlling Lantana camara. Very invasive with Lantana camara. Fish and common crabs. Can be used to fight aquatic weeds, that is growing in water. We can also use fungi. Example, there is a fungi named as Rhizoctenia blight, which is used to control water hyacinth. You've all heard about water hyacinth. Sorry, it is not visible here. It is water hyacinth. I hope you all have heard about water hyacinth. This is a very invasive aquatic weed. It is also not native. it is exotic weed. So here fungi, Rhizoctinia blight can be used to control water hyacinth. We've also got chemical methods. That is use of herbicides, example atrazine, simazine, 2,4-D. These are the some of common herbicides we have discussed in detail in package of practices. Hope you remember how these are helpful in controlling major weeds of major crops. So this is what integrated weed management is. That is combination of mechanical, cultural, chemical and biological method. Hope you understand it. Now moving on. In this lecture we will focus a little bit more on biological methods. So what is biological weed control? Biological weed control. What is biological weed control? It is use of living organisms such as insects, fish, snails, or even competitive plants for control of weeds. So, with use of living organisms like insects, fish, snails and competitive plants, the plants which can compete to weed. During competition they will suppress the growth of weed. So, this is what biological control is. In this method, it is not possible to completely eradicate. It is very difficult to completely eradicate weeds. But what we focus here on to reduce weeds to such a limit where they are not harmful, that is below harmful limits, reducing weeds to below harmful limits. So this is what biological weed control is. Its merits are how it is advantageous. It provides less harm to environment. There is no residual effect. In recent times we are seeing the problems of pesticide residue in food, herbicide residue in food, even fertilizers residue in our food, which is harmful to our health. So in biological weed control there is no residual effect. They are also relatively cheaper and comparatively long lasting when compared to chemical methods. They're cheaper and long lasting, and they do not affect non-targeted plants. Suppose in a field there are some non-targeted plants which are not weeds but they're also not crops. What happens sometime when we use weedicides, those null-targeted plants which are not weeds, sometimes they are useful to our crops also. They are also died. They are also killed due to the chemicals. But in biological weed control, those non-targeted plants are not been killed. They are safe. Here the targeted plant is only killed. So these are some of the merits of biological weed control. Keep making notes. It is very important. I have told you several times, the notes which you will have at the end of this course is your Brahmastra. More than maximum questions, more than 80 to 90% of questions will directly ask from your notes. I guarantee that. So keep making notes. Now what are its demerits? multiplication is costlier. Suppose we are producing chemical weedicides or herbicide, anything. So we can make them in factories, but can we make insects in factories? Can we make fish in factories? So their multiplication is costlier. It is a very hectic process to multiply the number of insects. So this is the one problem. Control is slow. In chemicals, we just put chemicals in the field, weeds are gone in some days. But in this biological method, suppose you're using an insect, we first introduce the insect to our field, then the insect establish themselves, then they start to eradicate or kill or eat the weeds, the leaves of weeds, damage their vascular system, damage their phloem, damage their xylem. So it is a long process. Control is slow. Success control is limited. Not every time it is successful. Very few host-specific bioagents are available. There is problem of very few bioagents are available. Problem of selectivity. What this means? Suppose there are 3 kinds of weeds in a field. 1, 2, 3. Suppose you are introducing an insect and it is useful to kill one weed. The one weed is eradicated, but still there are 2 weeds left. But in herbicides and chemicals, when you use it, the most of chances that it will kill all the 3. So this is the one more problem in using biological weed control. Some examples of biological weed control which you can use is, as I have told earlier also, let me rub it. Example, Lantana camara. Examples. Can be controlled by larvae of Crocidosema lantana. This is an insect. Cuscusta can be controlled by Melangomyza cuscusta. There is one more weed, Cyprus rotundus, can be controlled by Bactera virtuana. That is a moth borer. And we all know in aquatic weeds we can use some fishes like tilapia, we can use crabs, etc. So these are some of the examples of biological weed control. Hope you understood it. Now moving on to approaches of biological weed control. Approaches of biological weed control. So the first approach is classical approach. This is important. It has been asked in previous years. Classical approach. The main objective of this approach is to restoring balance between target weed and its natural enemies in ecosystem by introduction of suitable bioagent. By introducing suitable bioagent. Here what we do, we focus on restoring the balance between target weed and its enemies. The enemies will kill the target weed, and those are bioagents. What happens here? The bioagent kills weed, then bioagent dies with starvation, as all weeds are killed. But when weeds regrow, these bioagents may also recover themselves, so they will also be recovered. So here we create a cycle: weed kill, bioagent dies, then weed again regrow, then again bioagents recover. So this cycle is created in the classical approach. Now moving on, some of the examples of classical approaches are number one, insects. I've discussed many times. Lantana camara can be controlled by Crocodosema lantana. Aquatic weeds by crabs, fishes, etc. You should remember these important examples. When you will write examples in your answer, it will enhance your answer and you will certainly get very good marks. For we can use competitive plants. Example, marigold. Marigold compete with Parthenium species. Very common weed, Parthenium, and the marigold has a competitive advantage over Parthenium. So growing marigold will suppress Parthenium. We can use snails as they feed on water hyacinth. We can use mites. Example for one mite, that is Tyrannosaurus desertorum. Tetra, it is not Terra. Tetra, Tetranychus, Tetranychus desertorum. It helps to control prickle pear. It is a weed, prickle pear. So these are some of common examples of classical approach of biological weed control. Hope you understood it. What is classical weed control? Now moving on to bioherbicide philosophy of weed control. That is bioherbicide philosophy of weed control. What is this bioherbicide philosophy? Bioherbicides are pathogens cultured artificially and made available in sprayable formulations, just like chemical herbicides. So these are pathogens cultured artificially and made available in sprayable formations so that we can spray in our fields. They are also called as mycoherbicides. So we'll see some examples. Number one, there is a bioherbicides named Divine. Divine. It is a liquid suspension of fungal spore of fungus Pythopathora palmivora. It causes root rot in wheat. It has been very useful in controlling a weed known as strangler vine in citrus orchard. So it has helped in controlling a strangler vine in citrus orchard. This is all about, this is D vine. Now moving on to other examples. We have got Colijo. It contains the fungal spores of. It is in powder form. It contains fungal spore of fungus Coltroticchum glossiporidis. Coltroticchum glossiporidis. It causes stem and leaf blight in weeds. It is used in controlling a weed known as joint wedge. That is, its biological name is Eschewmon species in rice fields. And moving on to next example, we have got one more product, that is Biopolaris. It is suspension of fungal spores of Biopolaris surgicola. This is a fungus, and it helps to control a very common weed, that is Johnson grass. And the biological name of Johnson grass is Sorghum halipense. Suppose when you find difficult to remember biological name, you can certainly remember Johnson grass. And Biopolaris is used to control Johnson grass. If you forget the name of fungus or the scientific name of the weed, so you can use this, you can write this way also, but I am giving you all information. It's on you how you want to present it in your answers. So this was all about biological weed controls. Now moving on, one important question that has been asked in previous years, that is role of Bt cotton in cotton production. So as we all know, Bt cotton is an insect resistant transgenic crop. Insect resistant transgenic crop designed to combat which insect? Bollworm that affects cotton balls. It has been created by genetically altering the cotton genome to express a microbial protein from the bacterium. It helps in expressing a microbial protein which kills the bollworm, that is helps it to become insect resistant from the bacterium Bacillus thuringiensis. I hope you have heard this name, you have read about Bt cotton a lot of times. So this is what bacterium. In short, what this bacterium does, the transgenic inserted into plant genome, this transgenic from Bt, Bacterium thuringiensis, produces toxin crystals that plant would not normally produce. We all know without this alteration of this BT genome, the toxin crystals will not be normally produced by the plant. When this toxin crystal is eaten or ingested by a certain population of organism, it dissolves the gut lining. Dissolves the gut lining of the organism, that is bollworm of the insect. It dissolves the gut lining of the insect and leads to its death. This is what BT cotton does. Now, in recent years, BT cotton has got approval to be produced. What is its role? How it helped? Yield increased by 24% compared to conventional cottons. 50% increase in farmers' profit, which helps in enhancing standard of living of farmer, and profit enhanced, the standard of living enhanced. Because how 50% enhanced, only 25% of yield growth? Because here the income or the input which farmer was to add as the chemicals, pesticides, but in BT cotton it doesn't need it. So although the yield enhances, so the 24% of just yield enhanced leads to 50% of farmers' profit, as chemicals were not required as input, so it saved farmers money. It also reduced the use of insecticides, as I talked earlier. India's cotton export fell. India's cotton export grew, whereas import failed, or import was reduced, and India overtook China. India overtook China as biggest cotton producer in year 2015-16. So you can see how it has helped. There was one more advantage, that is it increased the expansion of cotton crop area. The crop area of cotton increased from 7.67 million hectare to 11.96 million hectare. From 7.67 to 11.96. So you can see how it enhanced, how it improved. Around 25 to 30% the cropping area was increased. So this is what was the role of BT cotton, but it had created certain challenges also. Challenges of BT cotton: expensive seeds, as it is genetically modified seeds, so it is expensive. Yet seeds can't be reused. So new seeds have been should be to bought every growing year. We have to buy new seeds every growing year. There was diffusion of illegal BT hybrids. The farmers were not so much aware, so illegal hybrids or fake hybrids were used in market in the name of BT hybrids, and some of the illegal hybrids hasn't cleared biosafety standards. Standards of these illegal hybrids was not cleared. So this can lead to environmental toxicity. and after some years, in some years, the yield also decreased. Not decreased, but it equaled the conventional yields. And the increase which was seen in the recent years were stopped, and the yield was equal to conventional yields. So these are some of the challenges of using BT cotton which we see in our country. So this is all for today. For any queries, just comment. If you like it, press the like button. Please like, share and subscribe. That's all for today. Have a nice day. Thank you.